Hey y'all, in this question we are going over the first graph on the back of the study guide where we're drawing a position graph, and then we're also going to make an acceleration time graph. So we're going to start off here with the position time graph. So when you're finding, when you're going to make a position time graph off of a velocity graph, the first thing you're going to need to do is find the area between the line and the x-axis for each section of your graph. So I'm going to go ahead and do that first, and then we'll transfer that information over to our graph paper, okay? So first off, let's break up the sections of our graph, and we want to break this apart every time our line changes direction or crosses the x-axis. So here, for the first 2 seconds, we get a nice little triangle, and then we get an equal size triangle from 2 to 4 seconds, and then it crosses our x-axis, so we want to switch. And you don't technically have to break it up at 6 seconds. You can go all the way to 8 seconds for this because it makes one giant triangle. And then last we get this polygon shape that we're gonna end up breaking into a triangle and into a square. All right, so now that we've done that, we can find the area for each section. So let's start off with the first one. From 0 to 2 seconds we have a triangle, so it's 1/2. Its width here is 2 seconds, and then its height goes from 0 down to -2, so it'd be -2. So 1/2 times 2 times -2 is gonna equal -2. Right. For the next triangle is actually the same size, so again it's just 1/2. It's got a width of 2 from 2 to 4 seconds, and then it also has a height of -2, so that's going to equal -2 as well. And then for the big red triangle, it's going to be 1/2 times its width goes from 4 all the way to over 8, so its width is 4 seconds, and its height goes from 0 up until 6, so you have 1/2 times 4 times 6, so that is going to equal 12. And then lastly, for our combo shape, we're going to have the square and the triangle separately. So for the square, it has a width of 2 seconds because it goes from 8 to 10, times its height goes up to 4, so that's going to equal 8. And then the triangle on top is 1/2. It has a width of 2 seconds as well, from 8 to 10, and its height starts at 4 and goes up to 6, so its height is 2. So it has 1/2 times 2 times 2 is going to equal 2. So when you add those together, you get a total of 10. Right? So that's your first step. First step to make a position graph from a velocity graph is find all of your areas, okay? So now we're going to go over to our graph paper, and we're going to always start these at 0. You don't technically have to, it just makes it a little easier. And now we're going to go up and down based on the areas we got. So if it's positive, we're going to add on. If it's negative, we're going to subtract and go lower. So for the first 2 seconds, we went to -2. So starting from 0, we're going to subtract 2, and we're going to be at 2 seconds, -2 down. All right. Then we want our line on our position graph to tell us the same information that this velocity graph was. So here we had a diagonal line that tells us we are speeding up in the negative direction because it was going a speed of 0, now it's going a speed of 2. So it's speeding up. So on our position graph, we also want to show we were speeding up. And to do this on a position graph, you need a curve that is getting steeper as you go towards the end. So it's going to draw like this, okay? So it's telling us the same thing. It's telling us it's speeding up in the negative direction. The descriptions match, all right? For the next section, we're going another -2. So you're already at -2, and you're going to go down -2 more. So that takes us to -4 at 4 seconds, okay? So you're adding it on, or in this case, kind of subtracting it, I guess. This time, though, your line is going from a speed of 2 to a speed of 0. So it's slowing down in the negative direction. So you want a curve that's telling you that matches that information. So in this case, you want a curve that gets flatter, all right? That's not drawn super pretty, but you get the idea, all right? So you want it getting flatter, all right? Now for the next section, the big triangle, we had an area of 12, so that's a positive 12. So since it's positive, instead of continuing going down, we're now gonna head up on the graph, and we're gonna go up from -4, we're gonna go up 12. So, and we're gonna do that at the 8 seconds, all right? So then if we're at -4, if we go back up to 0, that's up a positive 12, or sorry, positive 4 rather, from there, but we want to go 8 more to get to 12. So we're going to end up way up here, all right? So we're going from -4 up to 8 equals a total of up by 12, all right? So again, we added 12 to that -4, and that took us to positive 8. And then I drew a curve that gets steeper as I go there, because this diagonal line here tells me I'm speeding up. I was going a speed of 0, then I ended at a speed of 6, and so that tells me I'm speeding up. So I want a curve that gets steeper. That also tells me I'm speeding up, right? The last section from 8 to 10 seconds, I had an area of 10. So I'm going to add on 10 from where I was. So I was at 8. So I want to add on 10. That would take me all the way to 18. And then I want a line that matches that. So this diagonal line here tells me I'm slowing down, because I was going a speed of 6 and I ended at a speed of 4. So I'm slowing down. So I want a curve that gets flatter and also tells me I'm slowing down. All right. So again, just a brief overview of the steps here. Step 1, break apart your graph into the different sections. Find the area for each section. Then plot those points. And if it's negative, you're going to go down by that much. And if it's positive, you're going to go up from that much. And remember, you're starting where the last section left off, all right, as you add or subtract it. And then the last thing is to make sure your shapes match. So if it tells you over here that it's speeding up or slowing down, you want it to tell you on the position graph whether it's speeding up or slowing down, okay? All right, next thing to do with this question is to make your acceleration time graph. So with a velocity time graph, to go to an acceleration time graph, you're going to use slope. So your first step here is to find the slope of each section of your graph. All right, and to determine each section, it's each time your line is going to change slope. So here we're going sloping down, then we start sloping upwards, okay? So this first 0 to 2 seconds, we have a rise. It goes from 0 down to 2. So your rise would be -2. And then your run goes from 0 over to 2, so it would be +2 over, and your slope equals -1. All right. For this next one, from 2 to 4 seconds, your rise is a +2 because it's going from -2 up to 0, so it's a +2 rise. And its run is also from 2 seconds because it's 2 to 4, so that's a difference of 2. So your slope here is 1, all right? For the next 2 seconds, this continues the same slope the whole time, just like our area that's made this one big triangle. This stays the same, stays consistent or constant, so we can calculate that all at once. If you calculate it separately, that's fine too. You're going to get the same answer. Okay, so for your rise, it goes from 0 up to 6, so your rise would be +6, and your run goes from 4 over to 8, so your run is 4. So you're going to divide 6 by 4, and that is going to equal 1.5. All right. And then the last section here, you are going to find that slope, and that will be negative. It's dropping from 6 down to 4, so that's a -2 for the rise, and it's happening in 2 seconds, so it's going to be equal to -1. All right, so again, that's your first step for this, is to find the slopes of each section of your graph. Now you're going to go plot those horizontal lines on your acceleration graph. So for that same time segment, we're going to put a horizontal line at the slope. So we got -1 for that first section. So we're going to plot or put that horizontal line at -1 for those first 2 seconds. Then for the green section here, that was a +1. So we're going to put a horizontal line at +1. From 4 to 6 seconds, we had 1.5, and this graph paper doesn't show 1.5. We can kind of go in between 1 and 2 and plot it there. All right. And then lastly, we had back to -1, so we're going to plot it at -1. Okay. So then you can connect all these with little dashed lines, and you don't have to color code your work. I just do to make it easier for you guys to follow. But that is how you make an acceleration time graph. So brief review: you first break up your graph, find the slopes for each section of it. So that's anytime it changes slope or changes direction on here. And then whatever your slope is where these horizontal line goes, because they tell us that's our acceleration for this time segment is that number. Okay. So this is the same kind of graph paper I'm going to give you on the test. What this acceleration graph and what the position paper look like is what you're going to see on the test. So it'll already be labels and stuff filled out for you. Okay. But if you have any questions on how to solve any of this, please reach out and ask. Okay.